video, we're going to continue our discussion of synthetic division. And in this video, I specifically wanted to use an example in which we have missing place values, okay, and where we leave a remainder. Okay, so go ahead and get started. Take a look at our dividend, we have a fourth degree polynomial, x to the fourth minus 10x squared minus 2x plus 4. And I would like to divide this by x plus 3. Now, I have my reasons for wanting to divide out x plus 3, and I think we should start with that. Actually, remember, division is a nifty tool when finding zeros of a function. So let's go ahead and take a look at the graph of this function. I've already graphed it. And as you can see, it is a fourth degree polynomial, and it very well can have at most 4 real zeros, and certainly it does have 4 real x-intercepts or zeros or roots or solutions in this case. But I'm looking at this, and it seems to me like negative, somewhere around -1, but I'm not quite sure where that 0 is. Somewhere between 0 and 1 there's a 0, and a little bit after 3 there's a 0, but look at this, oh man. Somewhere around -3, I'm pretty sure that there's a 0 at -3. So certainly what I would want to do is head back over here and say, well, I think that -3 is a 0. Now, I want to be sure. I want to be certain that this is a 0. So let's talk about a few things. First of all, if this were a 0, if it potentially were a 0, you notice I'm talking about this very, very forebodingly, but if that were a 0, that would imply that x plus 3 is actually a factor. So what I'd like to do is know if x plus 3 goes in evenly, if it goes in and doesn't leave a remainder. Because if it does, hey, it's a factor. And if we divide a first degree thing out of a fourth degree thing, well, that's got to leave behind it, let's see, 4 minus 1 is 3, third degree thing that most certainly would be easier to factor than what I've got here, okay? So again, hey, we're doing this video because of synthetic division, so let's go ahead and get started, we need our upside down division bar, and I don't want to do that in that color. Let's do it in this salmon or whatever you want to call it. So when I mentioned missing place values, it's kind of like when we did long division. You'll notice that in our dividend here, we don't have an x cubed term. We don't. So we are very much responsible for filling in mentally, or at least, if not mentally, very, very, very physically here, 0x cubed. We have to have something to take that place value. So when I drop in our coefficients, okay, remember we're going to take the coefficients of every place value and drop them in here. So we have 1x to the fourth, none of these x cubed things, -10 of these x squared things, -2 of these x to the first things, and 4 of these x to the 0 are constant terms. The other thing is this. If x plus 3 is linear divisor, of course we couldn't do this if it was a quadratic or cubic divisor, but synthetic division is allowed to be done with linear divisors. If x plus 3 is the factor we're dividing out, we actually want to use that 0, or that when I set it equal to 0, what I get for x on the outside. So this -3 actually has to go out here. -3. If I'm dividing out x plus 3, -3 goes on the outside. Okay. So synthetic division, remember, works like this. We'll go ahead and start by dropping down this leading coefficient. So we're going to take that times our -3 out front. -3 times 1 is -3. That's what goes here. Let's go ahead and sum these. 0 plus -3 is -3, and we'll start again. Let's take this -3 now times the leading thing here, leading digit, and we get 9, which goes here. So now our -10 plus +9 is -1. So now we're going to take this -1 times our -3. I get a +3, and now we'll add again. So -2 and a +3 is +1, and now we'll take this 1 times the leading 3, and I get -3, and I get 1. Oh no. Well, did I do something wrong? Well, what I know is this. This is our remainder. So keep in mind with synthetic division again, the last term is our remainder. We're just going to go backwards and fill in what we're missing. So if that's our remainder, then this thing right here is our constant. This thing right here is our x to the first term and our quotient. This is our x squared term, and this is our x to the third term of our quotient, our answer. So we end up with, it seems, when I take this original dividend divided by x plus 3, we got the answer 1, okay? So like 1x cubed plus -3x squared plus -1x plus 1 plus our remainder 1 over the thing we were dividing by. Okay, so I want to clean this up a little bit here. Actually, we end up with x cubed minus 3x squared minus x plus 1, and our remainder of 1. It was a constant 1 over the thing we divided by, x plus 3. And so like in so many of my other videos, I realize I've made a mistake after I'm done. And in this one, hey, guess what? I didn't make a mistake. As a matter of fact, I'm being very, very sneaky on this, and I'm being a jerk. But take a look at this. We suspected -3 was a 0, but if we zoom in, check this out. -3, as a matter of fact, was not a 0. It's very close to -3, but it's certainly not at -3. But, you know, I did want to kind of give the illusion that it wasn't -3 on purpose, and the reason why is because, well, hey, division, again, we're doing this for a reason. We're doing it to try to guess at some of the zeros and divide them out so that what's left over is of lesser degree, than what I started with. So like, for example, my answer was a cubic. I might have more of an opportunity to factor that mentally with my factoring techniques than I would to factor the original. But again, I also did this video because I wanted you to see what it looks like when you have a remainder synthetic division, and also when you have to fill in like place values like this 0x cubed here.